Greetings, dear students. You are welcome to Onyx Success Call, a success call to all your advanced level and ordinary level A grades. I am your host for today, Salah Hans, and today we will be doing G.C.E June 2021 ordinary level chemistry paper 2. So we will start immediately with our questions. Question 1. We have been given the periodic table. I will do a little sketch of the periodic table that has been given. G, F, and H. So that is the brief sketch of the periodic table, representing elements from A to letter H. We have to first of all take note that these letters are not the usual symbols for these elements, but our question came with A to H, so we have to answer in terms of A to letter H. So our first question, A, using the letters from the table, select an element that is stored in paraffin oil. Using the letters from the table, select an element that is stored in paraffin oil. The first thing we must know is that all group 1 elements are stored in paraffin oil. That's the first thing we have to know, that all group 1 elements are stored. Now, group 1 elements comprise of lithium, sodium, potassium, francium, and cesium. These are the elements that comprise of group 1 elements. So, with respect to our letters that we have been given, we discover that only A is on the line, the group of group 1. So only A falls on that group for group 1 elements. That brings us to the conclusion that our element A is a group 1 metal, and also since all group 1 elements are stored under paraffin oil, A is the element that is stored under paraffin oil. So our identification of the element stored under paraffin oil is element E. Element E, that's question 1E, Roman 1. The element E is stored under paraffin oil. The Roman 2 part of it asks we should identify a reddish liquid and RTP, a reddish liquid. So if we are to eliminate elements A to E, elements A to E are metals. We already eliminate from element A to E. We discover that these are metals. So we should be working with F to H. But we can also eliminate, and we find out that element H is a gas, and we have been asked to identify a liquid that has a reddish color at RTP. So when we look at them between F and G, F and G here are known as halogens. F and G here are known as halogens. We all know that if we look at our periodic table critically, the first halogen is white in color. That brings us now to our element G. So F is also eliminated. It brings us now to the element G, which we accept the fact that it is reddish. G is a reddish liquid. Reddish liquid at RTP. So that's how we do to come out with answers when this type of questions are given in front of us. We go by elimination we eliminate the ones which we can eliminate, then we compare now the remaining options that we have to see which one is best suitable to answer that question. So F and G are halogens. They are both liquids at RTP, but G is our reddish liquid, that is at RTP, whereas F is white in color. So our answer here is G. That's question A, Roman 2. So we have G, element G. So question B, number 1B, it says we should write the electronic configuration of B. Write the electronic configuration of B. So, before writing the electronic configuration, let's come back to our periodic table. This is the element B. We first of all identify that element B is in group 2 of our periodic table. And if we are to count the squares before reaching at B, we discover that it is also element number 12. Since B is element number 12 of our periodic table, it means it has atomic number 12. The atomic number of B is 12. And if we look at from the notes we were given, the atomic number is the number of protons in the nucleus of an atom. So it means if the atomic number of B is 12, it implies B possesses 12 protons. And we were also told that in a neutral atom, the number of protons is the same as the number of electrons. So what is this implying? It simply means since there are 12 protons in element B, it means there are automatically 12 electrons in element B. So we come out with the electronic configuration from the number of electrons. So upon writing the electronic configuration, I'll abbreviate it as EB, EC of B will simply be from the number of electrons present, 12. We know that the first shell can take a maximum of 2 electrons. So the first shell has a maximum of 2 electrons. The next shell can take right up to 8, the maximum of 8 electrons. So if we write 8, this is already 10 electrons we have exhausted, and we discover that we are left with just 2. The third can also take a maximum of 8, but since we are left with just a maximum of 2 electrons from the number of electrons that were given, we discover that the third will take another 2 electrons. So our electronic configuration of B is 2 is to 8 is to 2. So upon writing the electronic configuration of B, this is what the markers are expected to see as the electronic configuration of B. So we move to our next question. Okay, so our next question, that is question B, Roman 2. This was Roman 1. So we are now answering Roman 2. Roman 2 says, why is B classified in group 2? Why is B classified in group 2? So if you look at this electronic configuration we saw in Roman 1 above, 2, 8, 2, we'll discover that the valence shell of B has a maximum of 2 electrons. That means it has a valency of 2. when you have a valency of 2, this last number on the outermost shell will tell you the group number to which that element belongs to, and also tell you the valency of that element. So we discover that it has a valency of 2 and it is present in group 2, since the last number on the outermost shell gives us the group number to that element. So this is simply because the element B has 2 valence electrons on its outermost shell, and it gives us the group number to which that element belongs to. So as our explanation, it is classified, element B is classified as a group 2 element because it possesses 2 electrons on the valence shell, that's on the outermost shell of the electronic configuration. We move to question C. Question C reads, the element E, we are now with the element E. The element E has a relative atomic mass. So, as you see, the relative atomic mass, that is the RAM of E, was given as 27. Give the composition of an atom of E, Roman 1, the number of protons. So here we have been given the relative atomic mass of the element E, and the first sub-question under Roman 1 is asking us to determine the number of neutrons, the number of protons, Roman 1 is asking us to determine the number of protons that element E possesses. If we come back to our periodic table, this is the position of our element E. Upon counting the squares as we did for B, we ended at B and we said B was element number 12. Upon reaching E, it will be element number 13. That means it has an atomic number of 13. And what does it mean for an element to have an atomic number of 13? We said the atomic number of E is 13. And what does it mean for an element to have an atomic number of 13? It simply means the number of protons from the definition we were given. It simply means the number of protons in the nucleus of that atom is 13. So we have already gotten our Roman 1 answer, that is asking us to get the number of protons